Good morning, everyone. So, I am going to discuss with you today Module 3 Variations, specifically direct variations. So, when we speak of variations, we are actually talking about two quantities. Okay, so more or less in mathematics, it's always the x and y. It always involves, x and y. Okay, so let's have this activity first before anything else. So we have here a problem. So let me read it to you. A local government organization launches a recycling campaign of waste materials to schools in order to raise students' awareness of environmental protection and the effects of climate change. Every kilogram of waste materials earns points that can be exchanged for school supplies and grocery items. Paper, which is the number one waste collected, earns 5 points for every kilo. So with this problem, a table is constructed to show the points earned by grade 9 class. That is for every number of kilograms of waste paper collected. So we have here the number of kilograms n. So with its corresponding points. So 1 kilogram corresponds to 5, and then we have 2 for 2 kilograms, we have 10, for 3 we have 15, and so on. So with this table, okay, given this table that we have, here are some questions for us to answer. What happens to the number of points when the number of kilograms of paper is doubled or tripled? So as you can see here, when the number of kilograms is 1, we have 5, and then when it doubles, it becomes 2. The number of points becomes 10. So it's very clear that it's also doubled. And then when it is tripled, we have 3 kilograms. It is also multiplied by 3, so 5 becomes 15. Okay, or the points becomes 15. Okay, so when the number of points is doubled, when the number of kilograms is doubled, the number of points is also doubled. And when it is tripled, similarly, the number of points is also tripled. Now, how many kilograms of paper, wait for a while. Okay, how many kilograms of paper will the grade 9 class have together in order to raise 500 points? Write a mathematical statement that will relate the two quantities involved. Okay, in order for us to answer these questions, so paano ba? Are we going to continue with the table until such time that we will reach 500 points? Okay, that's very tedious, no? So actually there is a certain way for us to be able to know whether as to how many kilograms will these grade 9 students have together in order for them to raise 500 points. And this is what direct variations is all about. So before we answer that, let's take note that there is a direct variation whenever a situation produces pairs of numbers in which their ratio is constant. So when we speak of ratio, so if we go back here, so if we go back to the table, when we speak of ratio, so that's basically points over the number of kilograms. So let's check in every item now. So we have 5 over 1 is 5, or I guess this is clearly shown if we're going to make use of the board. There is a direct variation if there is a constant ratio. So where is that ratio come from? So that's points over the number of kilograms. So isa-isahin natin sa 5 over 1. That's 5. And here we have 10 over 2. So that's 10 over 2. Still, that's equal to 5. And then we have 15 over 3. That is still 5. And for 20 and 4, we have 20 over 4. That is still 5. And 25 and 5. 25 over 5 is 5. And lastly, we have 30 and 6. And 30 divided by 6 is 5. So it is very clear that there is a ratio which is constant, and that is 5. So that explains why this is an example of a direct variation. So if a direct variation has this mathematical statement as y equals kx, and earlier we have solved for k by getting the ratio, the constant. K is the constant of variation, and by getting the ratio we get k equals 5. So therefore our mathematical statement for this problem will be y equals 5x. Now since earlier we were asked about how many number of kilograms is needed for them to have 500 points. So that's if this is the x and this is the y, so 500 will be for y, so we have 500. Just substitute 500 is equal to 5x, the number of kilograms. So basically we just need to divide, so we get the number of kilograms to be, what is 500 divided by 5? That's 100. So 100 kilograms will be needed to get 500 points. A direct variation for two quantities x and y, an increase in x causes an increase in y. Similarly, a decrease in x causes a decrease in y as well. So just earlier we were asked as to if the number of kilograms will be doubled, what will happen to the points. So we answered doubled also, and if it is tripled, then the number of kilograms, if the number of kilograms is tripled, then the number of points will also be tripled. That's for direct variation. So whenever x increases, y also increases, or whenever x decreases, then y also decreases. It's direct. Here is an example. If y varies directly as x and y equals 24 when x equals 6, find the variation constant and the equation of the variation. Okay, so we have the given y equals 24 and x equals 6. Now for the statement y varies directly as x, so y is kx. Okay, so since y is being mentioned first, so y must be placed here, and our direct variation statement is this one, so we have kx. Now for us to find the constant of the variation, we simply substitute the two given. So the given for y is 24 and x is 6, so we have k times 6. By simply dividing both by 6, so k is equal to 4. Okay, so we have k equals 4, and that is the variation constant. And for us to get the equation of the variation, we simply go back here and substitute k with the solved value 4. So the equation of the variation is y equals 4x. Here is another example. Now the table below shows that the distance t varies directly as the time t. Find the constant of variation and the equation which describes the relation. Okay, so we have the given. We have 1 hour and distance. So we have 1 hour is 10, 2 hours is 20, and so on. So how do we get the constant of variation? Earlier, I have shown to you if given the table, so we simply get the ratio. There must be a constant ratio. So if we have 10 over 1, so that's equal to 10. So let me show you the way. So to get the constant of the variation, you need to find the constant ratio. So just get the quotient of 10, distance over time. So 10 over 1 is 10. We have 20 over 2 is 10. And 30 over 3 is 10. Okay, so it's very clear. Even if we will not continue with 40, or if we will continue, so that's 40 divided by 4 is 10. 50 divided by 5 is 10. So more or less, the constant of the variation k is equal to 10. So how do we get now the equation of the variation? So if y varies directly as x, so we have y equals kx, and we have solved for k as 10, so that's y equals 10x, the equation of the variation. We have another example from here. So if x varies directly as y, then x equals 35 when y equals 7. What is the value of y when x equals 25? So first is to make an equation or express the expression if x varies directly as y in a mathematical statement. So since x is being mentioned first, so our mathematical equation must be x equals k, and then the second variable mentioned is y. So we have x equals ky. So in a direct variation, hindi siya pwedeng magkapalit. So whatever is being mentioned first, so that must be placed here. Okay, so x equals ky. Now for us to get the value of k, so we will make use of the first given. And the first given is x equals 35. So substitute. And we will be solving for k. So just retain k. And then the first given is y equals 7, so we have this one. And then after which, just divide both by 7 for us to solve for k. So 7 divided by 7 is 1, so that's k. And then we have 35 divided by 7 is 5. So k is equal to 5. And then go back here. So our equation now will be x equals 5y. Now, there is a question now. What is the value of y when x equals 25? So we will just substitute. We will substitute x with 25. So we have 25 is equal to 5y. For us to get the value of y, so simply divide both by 5. So 5 divided by 5 is 1. So y is equal to 25 divided by 5 is 5. So problem solved. We have an activity here, so it's your turn. Write an equation for the following statements. So our first statement is An employee's salary S varies directly as the number of days D he has worked. So, since there is no number for us to solve, so we simply make use of variables. So, the answer to this must be S, which is the first being mentioned, is equal to KD. Okay, so again, S equals KD. Okay, here is another one. The cost of electricity C varies directly as the number of kilowatt-hour consumption I. Okay, so again, there is no given values for us to solve, so we simply make use of the variables mentioned. So we have C equals KI because the statement is varies directly. So again, the answer to this is C equals KI. Another one is the fare F of a passenger varies directly as the distance D of his destination. So F is equal to KD. Again, F equals KD. Okay, we have another instruction from here. Determine if the table or graph express a direct variation between the variables. If they do, find the constant of variation and an equation that defines the relation. Okay, so here is the first one, table. Okay, so how do we know whether this table is a direct variation or expresses a direct variation or not? So, diba we can get a constant ratio if it's a direct variation. So, we simply divide y over x. Okay, let me show it on the board. Okay, so how do we know whether this table is a direct variation or not? So, we simply have to see to it that there must be a constant ratio for this to be called a direct variation table. So, we simply divide y over x. So, we have negative 3 divided by 1 is negative 3. And then negative 6 divided by 2 is negative 3. So, negative 9 divided by 3 is negative 3. And then negative 12 divided by 4 is negative 3. So it's very clear that there is a constant number which is negative 3. So this is a direct variation. And according to the instruction, if it's a direct variation, determine the constant of the variation. And more or less, we have already solved for it. So we have k is negative 3. Now for us to get the equation that describes this table, so we have y equals the constant which is negative 3 and then x. So this is now the equation of the variation. Here's another example, another table. So we will determine whether this one is a direct variation or not. Okay, for this to be direct variation, there must be a constant ratio of y over x. So if we will have 1 over 2, that's the first ratio, 1 over 2 or 1/2, and then here we have 2 over 3. So from 1/2 and 2 over 3, basically we can already say that this table does not express a direct variation because the ratios are not equal. What if the given is a table? How do we determine whether this is a direct variation table? Graph, I mean. The given is a graph. So how do we determine whether this is a direct variation or not? So more or less we need to find set of ordered pairs x, y. So we have the first is 2, 1. Okay, 2, 1. So if we are going to get the ratio of y to x, so that's 1/2, 1/2. Okay, another is, let me focus on the camera. So 4, this one, 4 and 2. So when we get the ratio of y over x, that's 2/4. And 2/4 is equal to 1/2, which is the first ratio that we got. Okay, so 1/2 and 1/2. So this table, this graph, I mean, is a direct variation in which 1/2 is the constant of the variation, and the equation that defines this is y equals 1/2 x, or we have here 0.5x. Okay, so this is a direct variation table. Here's another one. So let's get a set of ordered pair. We can have it, I think we can have it from 6 and 1, so that's 1, 6. Okay, so another is this one here, 3 and 3. So 3/3 is 1. So if we have 1/6 and 3/3 is 1, so this graph is not or does not express a direct variation. Okay, we still have more. In each of the following, y varies directly as x. Find the values as indicated. If y equals 12 when x equals 4, find y when x equals 12. How do we go through this? So how do we go through this? First is, of course, to create the mathematical statement, since this is a direct variation. So, and y varies directly as x. Okay, to solve for k, we need to make use of the first set of given, the 12 and 4. So by substitution, we have 12 equals x is 4, and then divide. So 4 divided by 4 is 1, so k is equal to 12 divided by 4 is 3. So we now have k equals 3. Now find y when x equals 12. So y is equal to 3. X is our final equation of variation. So solve for y when x is 12. So y is 3. Substitute x with 12. So 3 times 12 is 36. Problem solved. Here is another problem. If y equals -18 when x equals 9, find y when x equals 7. Y equals ax. So using the first given, substitute -18 is k times 9. Divide both by 9. We have k equals -18 divided by 9 is -2. So k equals 2. So our equation will be -2x. Find y when x is 7. So simply substitute x with 7. Therefore, when x is 7, y is -14. Another problem. If y equals -3 when x equals -4, find x when y equals 2. Create our equation. So y equals kx. Solve for k by substituting the first given. We have -3 for y, and we also have x as -4. So dividing both will give us, dividing both by -4, will give us k equals 3/4. Okay, so we have a fraction value for our constant, and then our equation will be 3/4x since our k is 3/4. Now find x when y equals 2. So substitute y with 2. And then we have 3/4x. Now, how do we get the value of x? So we simply multiply all with the reciprocal of 3/4 because this is a fraction. So the reciprocal of 3/4 is 4/3. So 3/4 times 4/3 is equal to 1. So x is now equal to 2 times 4 is 8. And of course, just copy 3. So x is 8/3.